morning, students grade 9. Today we're going to have our lesson online. I hope you understand and enjoy this lesson. Today's lesson is identify quadratic function. Now if I have ordered pair like this, okay, if you remember, this is my x and this is my y. Okay, so this is x and this is y. How to see if this function is quadratic or not? I'm going to make a table like this. This is my x and this is my y, and I'm going to write the numbers in. I have here 0, 1, 1, 12, 2, 20, and 3, and 13. So what are we going to do? We're going to take the difference between the x's and the y's. Let's see the difference between 0 and 1, it's 1. The difference between 1 and 2 is also 1. The difference between 2 and 3 is 1. So I have here a constant difference, okay? Let's see what about the y. Do I have a constant difference or what? If sorry, this was 6. Let's see the difference between the values of the y. Here it's what? It's 6. 12 and 20, the difference is 8. From 20 and 30, the difference is 10. And this is called the first difference. Let's see the second difference. We're going to make the difference between 6 and 8 is 2. 8 and 10 is 2. So I have here a constant difference in the second difference. For the second difference, I have here constant difference, so this is a quadratic function. Let's remember what's a quadratic function. If I said 3y plus 2x equal 4, this is linear function. Linear function with first degree. What about if I told you 3x over 2 plus 4x minus 3 equals 0? I have here the power of the x is 2. That means it's quadratic function. It's quadratic function. So look and see if it's second degree or quadratic function by the power of the x. Okay. Let's return back to our exercise here. Here this equation will be what? 2x plus 2y. We said it's linear. It's linear, it's not quadratic. Okay? Okay. Let's see the next question. I have here this figure, and he's telling me to use this table to get the values of the graph. What are we going to do? We're going to get this table and put the values. Let's start in from -1 and till -2. Let's change it a little bit. If I have here negative 2, negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, negative 1, 1, and 2. We're going to substitute here negative half times x power of 2, so it will be negative 2, negative half, and negative 2 power 2, so it will be negative 2. So if I have here negative half and negative 1, so it will be what? Negative 1, it will be negative half. And 0, it will be 0. And 1, it will be negative half again. And 2, it will be negative 2. Let's plug these numbers here. I'm going to start negative 2 and negative 2. This is the point. Then negative 1 and negative r. This is the point. Okay. Then 0 and 0. This is the point. 1 and negative half. This is the point. 2 and negative 2. This is my point. Then draw the curve. What I have here, the curve, I have a maximum point. I have this called maximum point. And it's called also a vertex. So my vertex equals 0 and 0. Okay? So this is called a vertex 0 and 0. If I have a vertex here, let's see 2 and 6. You're going to say this is the value of x and this is the value of y. Okay? And if it's the value of x, that means x of symmetry. X of symmetry. And this will be maximum or minimum value. Maximum or minimum value. Okay? So this point is called vertex, which is x and y, and x is 2 is my x of symmetry. 6 is maximum or minimum value. 6 is the maximum or minimum value. Okay? If I have here y equal negative 3 x power 2 plus 5. And he asked me if this equation opens downward or upward. For quadratic function, I have this. It can be like this, which opens downward, or like this, which opens upward. For this, the coefficient of the x is positive. Okay, coefficient of the x power 2, power 2, its coefficient, which is e, is positive. Here, the coefficient of x power 2 is negative. Okay? Okay. So here, the coefficient of x here is -3. And -3 is negative. Okay?